Hey everyone. So I am the tech lead in AI Center of Excellence. I'm Tamal. I'm part of the BFS APAC region. So today we'll be going through small agents. Let me share my screen. So yesterday you might have seen that we went through LangChain and LangGraph. Right? So today we'll be going through another framework called small agents. So when you go through all these frameworks, you'll see that they are kind of look and feel in a similar way because they function. Because what happens is, like, more or less whatever you see all the other agentic frameworks like multi-agent frameworks, so they are kind of made taking into consideration the LangGraph and LangChain. Like, they took the inspiration from there and then they build their own this is so you'll feel that is quite a bit similar, but again it will be different in execution, functionality, and what it can do. So today we'll be going through small agents by taking by building a simple agentic RAG. So we'll be using one document, split it, chunk it, and then we'll see how to converse that and how agents can be used to do those conversations. So let's dive in. So what we have. So small agents, again, it's very specialized, and it has its own functionality. We'll come to that in a bit. So what are the components? Like, we have these code agents. It's specialized in code agents that can autonomously generate and execute code to perform user-friendly tasks. We have tool calling agent. Tool calling, again, yesterday we saw that how it connected to the SQL tool, and it ran the queries and all everything. So here also we have the tool calling agents also. Like get weather is one of the tool, which if we give a city name, it will just give the weather of that particular city. And then we have integrations, like we have LightL and OpenAI, Anthropic. Again, all these frameworks are built in such a way that they are integratable with any other standard integrations with OpenAI, Anthropic, so that it is easy, seamlessly integrated with all these providers to use their functionality, their LLMs and all. And then it is a very streamlined architecture. So with tool calling, multi-step task execution. So you have the streamlined nature of the small agents. So what are the components? Like, we have an LLM code, like that's the brain, that's powers decision making actions for the agent. We have a system prompt. System prompt means that clearly aligns the parser to ensure consistent outputs. Like, we'll tell that how to behave. Like, system prompts basically means you're telling the agent to behave in a certain way. And then we have a memory for context across iterations, so that whatever the agent executes is gets stored in the memory, and agent uses those previous conversations and messages as reference when it answers the next set of questions and user queries. And key benefits: so combining small agents with agentic RAG intelligence, small agents adds reasoning, planning, and also tool calling, and then adaptability. Agent can dynamically adjust action based on the data. We have efficiency, so reduces manual interventions, and then security, safe execution of the codes, and then scalability. So all these frameworks, you'll see that these benefits that is getting, I mean, for small agents, more or less you'll find these similar benefits for other tools, other multi-agent frameworks also, because the frameworks are built in such a way so that it is easily scalable, it is efficient, it is adaptable to the existing environment, so that it is more configurable, and also it can be easily integratable with any system that is doing. Like, as I said, like all these multi-agent framework, even though they're open source, but they can be seamlessly integrated with the OpenAI, Anthropic, or any other standard LLM providers and platforms. So that is so they want to make it more robust and also scalable, so that they can use. I mean, we can use these multi-agent frameworks to build more complex systems and agents. Now let's dig in with an agentic architecture. So as I said, today we'll be going through agentic RAG with small agents. So this is a basic flow of how small agent fits and on the overall life cycle. So there is a query, there is an user input. This is a small agent. So, and then this is the database. Again, so yesterday we saw that there was a router which was routing based on certain conditions. Here also there will be conditions, like if the user query is related to the database, a loaded document. So we'll be loading on document to parse it. So if the user query related to that document, it will answer from that document. If not, here we have given a search tool, meaning that if it doesn't found that, so if that question is not found related to the document, then it will do a search tool. It will invoke a search tool. As I said, we have so many tools integrated in the SmolAgent. So it will invoke the search tool. Then it will see from where it can best get the answer, and then it will give the query. So this is how the entire flow. So this is one way of achieving that. Another way is, if you want to make it more simple, like if it's not found in a database, you just say that sorry, so the LLM can output, the agent can output saying that sorry, this answer is not relevant, or I can't find this answer in the database, like that. So you have to define what this condition should be. Based on that, the agent will execute. And then based on whichever is getting triggered, like if the query related to the document, and if not in the, so based on that, it will give the final response to the user. So let's dive in. So first, so for any agentic things, we have to install the packages and also import the relevant libraries. So we'll do that. Just to make the output a bit more simple, I have given this command, which will suppress the long output that it gives for installation. Like you'll see a very long things like when it's getting installed. So just to make it the UI more clean, and then we'll import the necessary libraries. And I have already uploaded a document here. You can upload any document, need not be the specific document. You can upload any document, and then at the end I'll show you where to change the questions, because the questions I've given here are related to the document, and few questions are not related to a document, meaning that I'll be invoking the search tool, and then it will go to invoke the tool, and then it will give the response. So as I said, like I have done this. So this is just a snippet of what is there in the document. And again, I'll be doing a splitting and just printing the splitted documents. It splits the documents accessibly. So there are 14. So it basically, the document got split into 14 chunks. If I want to print the first chunk, so this is the first chunk, and then this is the second chunk, like that. So, and then this is the third chunk, like so. Based on the 14 such chunks are done. So chunking, as I explained yesterday in yesterday's session, is very important, because LLM requires huge compute for it to process things. So if you give a very long document, it will become inefficient and it will take long time to process, which is ideally we don't want. So it's better that whenever you are processing a document using an LLM, you chunk it, split it into multiple chunks. The chunk size can be determined by you, or it can be determined in agreement with the business, like how many chunks is one. So all this can be configured, like if you want 10 chunks, 20 chunks, 30 chunks, based on the size and volume of the document it is processing, you can just define the chunks. Each chunks can be processed by the LLM, and it will make it more efficient and also easily retrievable. And it can do those similarity searches in the document, in the vector database, for it to easily give you the response. Then as I said, that I'll be generating embeddings. Here again, I have used Gemini. You can use any open providers for your, when you are experimenting. These are the embedding models available. So yesterday, during the LangGraph session, I have used Chroma. Today, I'll be using Fias. Chroma is from Google, and Fias is from Facebook, Meta. So these are very common and well-known vector databases, and free. They're freely available, and which is very good for experimentation purposes and all. So as I said that from vector database, what the LLM will do, when you ask a question, it will do a similarity search, and based on that, it will try to give you the response. So here I'm asking, what is the objective of data sharing? If I run this, it will give certain answers. So this answer, as you see that, so this answer you're seeing in a text format, but LLM is seeing it in embeddings, the vectors. So, and then when you ask this question, it will do a similarity search in the vector database, and based on the most relevant chunks, I mean, it is all numbers and all everything. So then it will combine, and then it will give you the. So this happened very fast. So once, so it can seem that all these things are stored in the backend, but it is stored in numeric format. It converts it into text format when it gives the output to the user. We won't be able to answer. And so if instead of this text, if there's a numbers, we won't be able to understand, but LLM will understand the numbers.
Okay.
So here again, I'll be using installing the SmolAgents and light LLM framework. So this you can go through. So there's a concept in NLP, as I also said, that how text getting converted into numeric numbers like vectors and frequencies based on word size and word frequencies and everything. So you can go through in NLP. And also you can try to understand like how similarity search work. Basically, cosine similarity is being used. So here it is again installed, and I'm just defining the retriever tool. As I said, like this is a RAG, retrieval-augmented generation. So using small agents, I'll be defining the retriever. Retriever, what it will do is basically based on the semantic search. It will retrieve the parts of the document that could be most relevant to your to my questions. Like if the user is giving certain questions, it will do a semantic search. So there is similarity search, and then there is semantic search. These are the two most popular search techniques LLM uses uh, to give you the response you need. So this is a, and then if it encounters any error, anything, so your search query must be a string, like it should be an NLP, natural language questions. And then I'm invoking search tool. As I said in the diagram, there's a search tool, right? I mean, if my question is not relevant to the document being uploaded, it will. So this is a document which I have used. Now, if my question is not relevant to the document, what it will do, it will invoke the search tool, and then it will try to find the answer. Yesterday we used Tabili search. Today we use the DuckDuckGo search tool. There are many as such. And again, I have used Gemini 2.5 Flash. So based on the API, the key that you'll be using, if it's free and all everything, then based on that, you should choose your models, or else what will happen is moment you will invoke a model, and if it's not supported by the free APIs, then it will say an error saying that this model is not, I mean, it's not part of the API free tier. So they are paid. So there are paid models also, but you should be able to understand like what are the pre models available when you are creating the API keys. So I am invoking the search tool here, and then retriever tool, search tool, both it will work, and then it will give an answer. So tell me about analytics Vidya. So if I do this, it is invoking. As you can see, it is invoking, and so these are all the websites that it is referring to give you the answer. And then it, in the end, it invoked all these things through the search tool, and then it parsed. Parse means it took all the questions, all the responses from here, and it came up with a summarized version, and then it is giving you the output like this. Another one, if I say what are the constraints for data sharing? So this one, as I said, this is relevant to the document. So here the difference you can see. So here this question was not relevant to the document. So hence it invoked the search tool, and then it went through all these websites to collect the answers, and then it gave you a summarized version of the summarized answer from all the links that it has referred. Now here, since this question is directly related to the document, what it will, so instead of that, it just directly took it from the document and it gave you, sorry, gave you the output. So it did not do search. It just took it from here. So these are all parts of the document. Document 1, 2, 3 means So it is referring to the split, the chunked documents. As I said in the beginning, we did the chunking, right? I mean, say 14 chunks. So it's so based on whatever questions that you have asked, it found that from document 1, 2, 3. So it just went through the chunks. It took only the relevant chunks which is relevant to the user query. And then it took all these things and then it summarized it in the end. Again, what are the objectives of data sharing? See, again, it is going through this and then it is giving. So this is the difference between the search tool and so in the, so just I'll come to that. So what we did today, so we did load and process the PDF document, split it into smaller chunks, generate embeddings, the vectors, create a vector database, defines a custom tool for retrieving relevant document chunks, then set up the small agents to answer the query based on the retriever and the language model. So here, if you refer to this diagram, again, some of the questions were related to the document, in which case it was processing this part, and some of the questions were not related to the documents, and then it was invoking the search tool, and then it was fetching the relevant answers from all the links, and then it was summarizing it. So this is how the tool functionality along with the agents is. I mean, we use the tool, so it just extends the capabilities of the agents. So instead of saying no, I don't know anything, what if we define a tool and then the agent will invoke the tool moment it sees a question which is not relevant to the input, I mean, not the database it is tied with. So this is how we extend the functionalities and the capabilities of an agent. So
Great.
this is it. So yeah, I'm open to questions.
Great. We have one question from Ashish. He is asking that what is the difference between the yesterday LangGraph and LangChain and today's small agents, and when to use which one?
Ah, good question. So LangChain and LangGraph and small agents, so these are all multi-agentic frameworks. So there's no difference as such, like difference in the sense that yesterday I was showing one multi-agent framework, today I'm showing another multi-agent framework, because in market there are so many multi-agent frameworks, and the way to choose the multi-agent framework is based on what kind of questions you're trying to, or the objective or the business problem you're trying to solve. Now, it can happen that that most commonly used multi-agent framework is LangGraph, because it is easily, I mean, you can use it easy. I mean, it's very easily integratable, and it also supports a lot more functionality. But having said that, these are also multi-agent framework, small agents, which can be used for specific purposes. Here I have shown you a very basic setup where we are building a RAG, agentic RAG, and we are using small agents for retrieving and processing information. But you can use small agents for creating say complex applications also, similar to how we did for LangGraph and everything. So it's, I mean, there is no difference as such in terms of, but it's like one tool that, so yesterday I have shown you one tool. Today I've shown you another tool. Tomorrow also I'll show you another framework. So when you know all this framework, it's easy for you to choose between the frameworks, and then you can use it to solve your problem. And it can happen that for any complex application, I mean very complex, I'm saying, you can use one or two multi-agentic frameworks also. I mean, which can work in ensemble method or in an orchestrating manner. So that you can use. So those are very complex applications. But to keep it simple, like either you can use LangGraph or small agents, or so tomorrow we'll be going through CrewAI. So based on whatever questions you're trying to solve, how you are defining your multi-agentic system based on the business problem, based on that, you can choose your multi-agent framework.
Great, great. Thank you so much, Tamil. It was really a nice session. And you just provided a very clear and engaging session, actually. Your introduction to small agents and the way you explained how to build the flexible agents with minimal overhead while retaining full control over logic and execution made the concept both practical and easy to flow. Till then, Tamal, we can take another question.
Yeah,
Uh,
sure.
Mrinal is asking, it means internally small agents using search tool if the things is not relevant with it. Uh, It means small agent is actually using a search tool inside internally if things are not relevant with it.
Internally means like small agent has the tool capability, tool integration. So it's like not relevant. Yeah, in terms of the user questions for agent, it might not be relevant to the document that I mean. If I'm taking the example of today's session, if the document or the knowledge base that you created based on which the agent is trained, and if an user asks a question which is not relevant to the input, so instead of giving, say, sorry, I can't, which is a very valid output, but sometimes what we do is we'll do a search tool, integrate a search tool, and then we find the answer and then give it to the user. So it's like up to you how you are designing the system. Again, it's perfectly fine if the agent is giving the output like in I don't know anything. So this is one of the guardrails. Say for example, if you want to prevent the LLM from generating any hallucinatory answers or anything like that.
Rakib is asking that can we build LLM if we have resources like computational powers and space?
Yes, you can build an LLM if you have enough compute power, because to build an LLM, it requires huge amount of data. Like if you have enough compute power, because what I can tell you just for perspective, like the OpenAI model, the GPT model, it took the entire model took about 1 to 2 months to train. So it used like supercomputers. So if you have enough compute power to train a model, you can build a model, or you can use an existing model to and then fine tune on your own data. That is also another alternative. So yeah, but if you have enough compute power, you can build an LLM. Yeah.
Great, great. So, what you will recommend? Smita is asking that what you will recommend to us. Shall we go for LangChain, LangGraph, or shall we go for small agents?
Again, there is no right or wrong answer to this, and say like use this over that. So it's based on your business problem that you're trying to solve. You have to go through all the frameworks, whatever is available, how they work, and how they are made of, what are how they work, how they integrate with the system, and based on the kind of problem that you are solving, you have to choose as a builder, like okay, I'm using this or I'm using that, like that. Or sometimes it can happen that if you are in a business environment, like sometimes some of these frameworks are being told like, okay, we have to use this to build it because of certain things, and but then it is very open to the builder, whoever is building the application. Like you can use any of the framework to build an application. It's not like you have to use this or that or something. Like, it's based on what kind of problem you're trying to solve.
A dynamic, impactful continuation of season 7 of Hands-On Challenge Series. And tomorrow we will take the next exciting leap forward, CrewAI, where multiple AI agents collaborate as a team. On day 3, we will explore how individual agents come together, coordinate tasks, share responsibilities, and solve complex problems collectively using CrewAI. So, heartfelt thank you, Tamal, for the clarity and confidence you brought for today's session, and your explanation made abstract ideas practical and empowered everyone to build with purpose. And to our incredible audience, also, thank you for actively learning and building with us. We hope today's session inspired you to think smaller, build smarter, and move faster. See you tomorrow for day 3. Until then, stay tuned, stay curious. Thank you. This is Shruti Kurana signing off.